Good morning. Right on the heels of that Electrohome chassis repair and upgrade and whatever, it has been sent down to my woodworking shop where I will make a case for it in due course. But in the meantime, I thought I'd just quickly get back on track. And what I have here on the bench is a Clairtone, all tube, and it is, according to my manual, a chassis type s403, okay, used in various models. It's one of the better Clairtone chassis, and it does have push-pull 6 GW8s, okay, in each channel, and FM and AM, a multiplex, which I've had various versions of that they don't seem to function anymore, and I'm really not enthusiastic about being able to get it running because it's equipment that I really don't have. So what I have done so far is I've tested the tubes, and I believe all the tubes are okay. I may be wrong about that, but I did the tube testing a few weeks or a couple of months ago, and I'm not really sure. But what I did do, if I can tip this fellow up and show, the front panel on these stereos is made of some kind of a, I don't know whether it's a pot metal, but whatever it is, over the 60 odd years of being in existence, it corrodes like you wouldn't believe. It's awful. All of the labeling and all that gets worn off, and it's unsightly to the extreme. So what I did, this was the first one, sort of an experiment with, I took the front panel off, took everything off of it, including the escutcheons and all the plastic stuff, and detached it from the chassis, took it down to the shop, and I sanded it evenly with a heavy grit to get all the corrosion off, and then with a finer grit. And then I found a can of spray paint that mimics aluminum, and I've sprayed it, and it is okay, although I found out that I should actually have topped it with a finish spray like of lacquer, and I didn't do that, and so everything I've done here shows various things. I'm not overly worried about it. Then I made water slide decals, and I have applied them all. Now, the ones missing here I have ready to go. They didn't turn out so well, and I removed them, and I have subsequently made new ones, but I haven't applied them yet. And then the controls here all have labeling on them. I think I went down afterwards and sprayed it again, and it accentuates the label material to some degree. From a distance you don't see it, but you can see it there. I'm not that crazy about it, but it is what it is. It's a lot better than it was. Okay, so we're going to get into this together. And I don't think I've powered this up, and I will do so, and we'll see what happens. Now, the connections for speakers, for the internal speakers, are there, and remote ones are up here. So I have to turn it on its side and maybe even turn it on its back. We'll see what it rests on. I don't want it to rest on the tubes. And it does rest on the filter caps, so that's okay. So I have to remove these connectors, and go for the ones that have an alligator clips on them. And that would be that, if I can get them out. Okay, I have 2 sets of clips. Let me back that out a bit. No, that's it. I have 2 sets of clips. Ones that go into the ports on my dummy load, and the others either have bare wires to go into speaker clips or these kind of clips here. So let's get it hooked up. First the right speaker, and at this point it doesn't matter which channel I'm using it on. Let's see. Let's go there and there. See if we can get the phasing right. And there and there. And pick up that one. And that one. Okay. Now, let's try and get that out of the way. Plug it in. I will put it on dim bulb and turn the... Okay, and then we have to turn it on. And the dim bulb comes up, sort of dim. It's not glowing extremely bright, so that's not too bad. Now we have to pick FM and turn the volume up, and I think let's just see what happens. Nothing nasty's happening. All right. I'm getting something there. Well, it works. Let's turn the volume down before we get... All right. Because it works, we're halfway there. Or maybe. All right, we're drawing 74 watts at 105 volts. Let's crank it up. Okay. All right. I think that's all we need to have here. The next thing will be to see what capacitors need to be replaced. Now, filter capacitors at this age will have to go. Now, the strange thing about this design that Clairtone did is that for upper middle quality, they use 1 diode in a half-wave rectifier, which I think is rather ludicrous. However, it is what it is. And now I have another one of these chassis where I have decided that I would put a full-wave rectifier in. It only has 2 wires for the secondary, so you can't put a full-wave rectifier in without a center tap. There is no center tap on this. So you can put a bridge in. Now, when I put the bridge in, the voltage was a lot higher because obviously the rectification is a lot more efficient. And in that case, I had to put in a big power resistor to drop the voltage down to something reasonable. So in this unit's case, I don't think I will do that at all. This was Clairtone's design, and we'll just live with it. So the capacitors that are in the circuit for the audio are ceramics, and they don't generally leak, and so therefore they're usually going to be okay, and I don't necessarily need to replace them. They do become microphonic, and if I find that with any of them, I will replace them all. The resistors, electrolytic bypass capacitors, this one in the FM, this one somewhere in the IF chain, all of those will need to be replaced. And I think, as I did with the Electrohome, I might decide to restuff something. The problem with the Clairtone, the initial one, is just a single unit, a single capacitor in a can, and I think this is 100 microfarads. I can check that out if I can find it. There's the schematic. Okay. Let's tilt this back a bit and zoom it in. That's going to be problematical with the reflection. Let me kill some lighting. See if that doesn't help. It's still rather faded out. However, I can use a pointer and point that out. First of all, the power supply, as you can see, uses one rectifier. Let's zoom that in a bit more. Yeah. Not happy with that, but it is what it is. All right. And the first capacitor, which is that single unit in a can, is 100 microfarads. And then we move over after resistors are placed for the various other parts of the circuit into the other can. So if I replace this, I could probably pull it to pieces and put the 120 microfarad in there. I might even be able to stuff one of the ones from the other can in there. In that, the other can has 4 capacitors in it, and I doubt if I'd be able to stuff 4 capacitors in that sort of thing. As you might see, let's back that off. There's not a lot of room. Let's get this inward. Okay, where are we? There is the 4 capacitor in a can electrolytics. To put outboard capacitors there, as you can see, it's kind of tight. This whole chassis is really kind of tight. So I would like to restuff it with 3 and then maybe put 2 over there, which means I'd have to do some wiring across there. Other than that, other than checking some resistors, it would be ready to go, and cleaning the switches up top and the controls. But that it works right off the bat is amazing. This sat in a garage while the house was being completely rebuilt. The cabinet and everything was covered with mud and dirt and dust and God knows whatever. It was going to go to the dump, but one of the construction guys thought that was really not a good move. And so they put it up on, I don't know whether it was Kijiji or what it was, for free. And anything for free, I'm willing to go get. So it was about 45-minute drive to go and pick it up. And we picked it up in the middle of construction. The cabinet was beyond saving, and so it went. The changer was a Garrard and Type A, and it got resurrected and sold. So this is what's left. How it performs after I get it all done, we'll just have to have a looky-see. as you can see, compared with the Electrohome even single end, these are pretty small for push-pull. They perform. I'm surprised with the other unit that I built is they have a reasonable fidelity, but this is the cheap end. They should be double this size, but it wasn't. That's what they've got, and that's what they put in it. So that's what we're living with. So at any rate, not much for me to do. I'm not going to try and actually, I might, when I get the capacitor out, try and give a video of how I get this innards out and do what I have to do with it. Since how on the last one I lost the video completely of what I had to do. At least it gives you an idea of the way I restuff an electrolytic capacitor. At any rate, so that's it. Part one of this Clairtone. What did we say it was? I forgot already. It's a Type 403. It's I pardon me. I've had older ones than this, which have very much smaller toggle switches up there, and use 6BQ5. So they're a generation earlier. They did pretty well. I got that particular one probably back in the 70s when somebody was trashing their stereo and I took the chassis out of it. So I repaired it and rebuilt it and actually gave it to my mom and dad to use as their stereo system for quite a few years until they decided they didn't want it anymore. And I'm not sure what happened to it. It just sort of went bye-bye. So that's it for now. Thank you for watching. And if I can manage to show the restuffing of a computer, yes, let's restuff a computer, a capacitor, then I will do so and show it as best I can. And we'll see how that goes for this. And that'll be the next major piece of work that gets done on it. Okay, thank you for watching. Take care. As per the last video, I have removed this capacitor, 100 microfarad at 350 volts, from the chassis just to the left there. The tabs, the twist tabs, have been damaged. In order to get it out, I can't see an easier way to get it out than that. So what I'm going to try and do this time, instead of cutting it around there, I'm going to see if I can remove this ring, and it's not beginning to look likely. It is prying. Oh, it does. Okay. Of course, I'm damaging the relatively soft aluminum as I'm doing it. All right. Now, the problem I'm having is getting this aluminum flange bent back and not having it look too bad a shape, which it already is. May mean I cannot go any other way. Okay, now that. Oh, see, now I'm bending it back again. This is not easy without jamming this into my, yeah, there it goes. The aluminum's very soft. It looks like it's glued in, actually. Well, not really, if you can see that. Oh, yeah, but what is this mess inside here? Oh, dear. And there's a piece of vinyl plastic. This may not work at all, not like the others. There is some kind of a tarry substance in there, and I have to get through that. Oh dear, that doesn't look good. All right, out comes the Dremel, and I'll cut that and see if I can get anywhere with that. Now this is going to make a bit of noise. I may want to edit this part out. We'll see what we can do. Okay. I think I'm past that. Yep. Okay. Hope that wasn't too noisy. Let's get this off. Okay, now we're past that. That is a newer technology than what I've encountered so far. Now I have to dig into this. This is tight. Oh, it's moving. And there it is. Okay. That's what the inside of an electrolytic capacitor looks like. And this is the mess that's inside. So again, yeah, it's a tar. It's not as bad as the other one, but it's a dried up tar. So again, I'm going to have to go down to the shop and let's see what we've got here. This is typically just as a trial fit. There's a capacitor that would go into the end. Now, if I can find a 45, I'm running low on these fellas. Well, you know, I might be able to stick 2 in there, and that would make doing the other one a little easier. So, okay. I'm not going to show taking the garbage out of that, and I just put this up against the grinder and clean that off a bit. Then I have to drill this and score that and then make it ready. So I'll do all that off camera soon, and then I'll come back and show, hopefully, stuffing 2 capacitors in there. That should work. Okay. See you soon.